A log is the inverse of an exponential function. So if we took our exponential function looking like this, so here's our exponential function. Okay. Anytime you take an inverse is just going to be reflected across the line y equals x. So this black line if we take our function and we reflect it along that black line, we're going to get our the graph of our log. And so if I'll draw that in kind of a thicker solid line. Okay, so if we fold this over across this line, we wind up with a graph that looks like this. Okay, so here is our basic log function. This is log with some base of x. Okay, again, as long as our b value here is greater than 1. If b is a fraction between 0 and 1, then instead of it being the inverse of this growth function, it's going to be the inverse of a decay function. So the general form of so if I take, and instead of this being again a growth function, if we had started with a decay function, which would look like this, and then we reflected it across this y equals x to get our inverse, the graph would look like the following. And so we take this this graph right here, and this part gets reflected down here, and this part right here gets reflected up here. And so this would be the graph if b is between 1 and 0. Okay. Again, remember there's two different kind of versions of the log graph. It all depends whether your base is a value greater than 1, or a value whose absolute value is greater than 1, or whose absolute value is less than 1. There's a fraction. And so this is your generic log form. And this is what a log graph kind of generically looks like. Log base b of x. Okay, but this is the case where b is greater than 1, and that's usually going to be the case. So on this, all the different shifting and reflections and stuff that have occurred in any of the other graphs are true for this one as well. Okay, so if I gave you something like log 3 of x, and I'll just kind of go through. Okay, so if this is the function that you're looking to graph here, so we'll call it f of x. Okay, all of the different transformation rules that apply are true for this. Since our base is a number greater than, whose absolute value is greater than 1, here's our general form. Okay, so again, make sure you, if you need to note that for yourself, make sure you write a note there. Okay, and then the shifting that occurs is where? So horizontally, the shift is okay, Josh, this is for next week. Okay, so the shift is left 2, and then the vertical shift is down 1. So we're going to take this graph, we're going to move it left 2, so 1, 2, down 1, okay, and that becomes our new graph. Now, there's one other thing that this brings up, and that is that just like with the exponential that has the um, asymptote at y equals 0. The asymptote for a log graph is going to be vertical. Okay? Okay, and so the normal, in just the generic form, the vertical asymptote is x equals 0. So which of these shifts is going to affect the vertical asymptote, the horizontal shift or the vertical shift? Which one moves it along the x's? The horizontal one. So when you look at this graph, we take and we shift our horizontal asymptote 2 to the left, and all of these other pieces get shifted down 1 over 2. And so the sketch for this graph here would look like the following. And so again, here's the point, left 2, down 1. So it's going to go through the point in that fashion. Okay, so that again is your general form. The base affects it slightly, but we're just looking at the general form of this. And now, if we take this and compare it to the following, and what if we were asked to sketch the graph of g of x, and this time it's log base 1/3, and everything else is just the same. Okay. So the only thing that changed here was the base of our log is now a fraction. It's an absolute value smaller than 1. So now the new kind of generic form for that is going to be, again, it's kind of the reflection of this. So the generic graph would look like this. And so now when we do our shifts, it's still left 2, down 1. So this gets shifted 1, 2, down 1. The vertical asymptote gets shifted 1, 2. And then we have the generic, or it just fits that general form. In this case, it comes down and over. Okay, so the shifting, the transformations are all consistent with everything else that we've done graphing-wise. The only difference now is, and let's really quickly, I guess, go back and look, because they are going to ask you to identify the domain and range for these. So let's look at this f function. So if we look at the domain and range for this, what's the domain on this black graph here? Remember, domain is the x value, so it's the furthest to the left it can go with x's. It goes up to, but doesn't include -2. So that's our left restriction. And so since it's an asymptote there, it doesn't actually include it, so it's a parentheses. And it extends all the way to infinity. Okay, and then what's our range? What's the lowest y value? Goes all the way down. What's the highest y value? All the way up. So it goes from -infinity to positive infinity, all real numbers. In this g function here, is there any difference between what we're looking at? What's our domain? Same thing, right? The furthest to the left on the x-axis is -2, doesn't include it, goes all the way to infinity, and our range, what's the lowest value? Goes from -infinity all the way up to positive infinity. And once again, if you were asked to describe the graph, this graph goes up and to the right. So again, even though it's going down and to the left, and it'll continue to move to the left ever so slightly, but it is moving to the left, but it gets stopped at -2. So we'll describe this as going up and to the right if it has a descriptor, and this one's going to go down and to the right as the description. Does everybody see that distinction? So this one is down to the right. So even though it goes up and to the left, it never crosses this point, so we'll describe it as going down and then just endlessly widening to the right. This one is up and to the right. Okay, I think these are the only pieces of information I asked on the graphing questions.